Thanks everybody for being here. I'm humble and very grateful to have the opportunity to share this story, this experience with such an amazing audience of passionate people. It's all about orchestration, isn't it? Over the last 36 hours or so, many of the talks, many of the keynotes, many of the conversations we had brought to our attention the multiple facets of orchestration, specifically service orchestration, and how Camunda can play an important role in tackling some of the challenges in orchestration. When I think about orchestration, I have a mental model which kind of brings me to a picture like the one you see on the screen right now, the orchestra. However, as much as this represents a great human achievement, if you look at it in terms of software development, that would be a pretty horrible nightmare. I argue that what we should be striving for as developers when we build our software is more akin to a music box. We want something that is nimble, we want something that is predictable, we want something that is testable, we want things that can be reused and replicated. Off you go. Imagine that the services, their bounded context, the capabilities of a systems are all included in this box. The great thing about it is that we get constant delivery of our business objective, with one big caveat, which is obvious. If you want to change the music, you got to change the box, or you got to open it up and change the gears and pins and comms. It's very difficult to change the behavior of a system like this without changing the fundamental components that makes the music box an instrument. The way I see BPMN is very much like the punch card that you would use to provide different behaviors. Given a set of constraints, given a set of capabilities, we can model different ways for the services and all the parts that are available in our systems in order to do something that can be potentially very different. It is true, this music box will always play with the same pitch, but we can play an endless amount of music with it. So it's all about workflow customization. Hold that thought for a second, because we got a little bit of business context to set. A turnkey and yet highly customizable solution. The two characteristics seem to kind of fight against each other, because this particular project required a high degree of flexibility to accommodate several different requirements within the scope of an acquisition platform. It could be for end users as well as for brokers. So the main scalability issue here was on the one hand the business scalability. How many new partners can we onboard within a year? And also the IT scalability, how much it costs to bring a new deployment to market, and how much it costs to maintain that in terms of infrastructure, in terms of cloud resources, and future maintenance. Several factors are at play here. We have different products and how they're configured. We have multiple distribution channels, direct to consumer, B2B, several different types of possible underwritings, a lot of constraints that are set by regulators, which have different rules in different jurisdictions. and the inevitable requirement to interoperate with existing systems, for example, ERPs or CRM, having a completely different set of notifications, communication systems for each specific distribution partner. The dichotomy here is, again, between standardization and customization. So how can we deal with that? Back to the music box analogy, all the services that we have available are the gears and pins, the components that make the box itself, and Camunda, BPMN, platform configuration, a bunch of other things that hopefully I'll have the opportunity to talk about, give us the ability to produce a completely different behavior, a completely different solution by reusing essentially the same building blocks. BPMN as a configuration. Typically, you would have a client, whether it's an API client or a user interface client, where users, agents can purchase insurances. And this example, you will have a very traditional input-driven interface, so that it's possible in the next step to get a quote. But what if the client has a completely different view, not only in terms of user interface, in terms also of what the backend has to offer? Instead of having the user to input a lot of different fields, we offer them 3 options based on whether they are millennials or Generation X and Z. That is obviously something that has a high impact on how user interface is done, but it also changes a lot of the behavior behind the scenes, because most likely that configuration sits somewhere in a client system, because we will need to have a different workflow. We will have to deal differently with the progression of actions within the process. This doesn't come, of course, without several technical challenges. The main one is that we want to give more responsibilities to the BPMN, because we said, ideally, we don't want to change anything. We don't want to write code. We want to have new workflows, new DMNs, new resources, and completely change the behavior of what we've done. And by doing that, we don't want to transform Camunda into a scripting engine, a runtime environment where we write thousands of lines of scripting code in order to customize our behavior. So how can we get BPMN to handle all the business logic? How can we do it at scale, performance-wise, more than anything? How can we leverage a set of standardized services, catalog services that are built in the container that runs the BPMN, and how can we extend it with additional capabilities? While we're doing this, we want to have extreme trackability. We want to have traceability and a complete awareness of everything that happens within the process, particularly when things don't go as we expect. This is what we ended up with, and now I'm going to describe every single task in this picture. Obviously not, but this gives you a glimpse of what the reference implementation looks like. This is the blueprint that developers, analysts, business people would take in order to quickly get to a minimum viable product, perfectly functioning, production ready, that can be tweaked, modified, and customized to fit the specific needs of new deployment. So you see there's a bunch of BPMN stuff, but there's also significant amount of DMN too. Everything has to be simple. I like the music box for a reason. And everything needs to somehow fit every possible use case that we may come up with. In principle, you could use the very same platform to do something that has nothing to do with insurance. It could be e-commerce, it could be, you name it. So the interaction entry point in our system is REST-based and essentially has the simplest API you could imagine. It has three things. One to create process instance, one to update it, and obviously another one to fetch the data out of it. We have a similar concept of some of the things that have been presented before. The schema is super simple. It expects a command and a payload. A command is the intention of what you expect the process to do. And the payload is an arbitrary JSON structure. Commands as well as payloads can be constrained and defined by the BPMN author in order to perform whatever operation it desires. This is a little bit how it works. Essentially, commands correspond to BPMN events. If you wanted to add a new capability, which is, for example, send email to client, and that's something that is not available, and it's something that we want to trigger from a button in the user interface, how do we do that? Well, we add a new command, which would be an event. We add a little piece of business logic, which would, guess what, send an email, and then go back to sleep in that event-based gateway, waiting for more events to be sent. Now, this talk starts with reactive microservice orchestration, and I guess many of you wonder, what the hell is this reactive thing? Well, we said we want to have extreme scalability in the way we configure things, but also in the way we execute things. We don't want to set up thousands of machines or end up in situations where the throughput of our processes is too bad. And BPMN executions historically have this particular trait that they like transactions, they like to be synchronous. And Camunda is synchronous too. So if you have a microservice system, but most likely you want to delegate services to do their job, which means that most of the time you would just be waiting for those things to do what they're supposed to. So when I/O occurs, we're just waiting for things to happen, and that's wasteful. ASYNC boundaries are not a solution, actually make things worse, because we have even more threads that at some point will be waiting for some things to happen. And if you want to run things in parallel, typically in Camunda you would use asynchronous boundaries. You probably would need to have a third one, just in case you get the infamous transaction inconsistency error. So the way to go is to make everything reactive, is never to have to block. You see in the picture here is essentially the flow of execution is never interrupted. Behind the scenes, there's an event loop that takes care of all I/O and will notify us back when things are ready. Camunda executed in a reactive chain. Camunda typically borrows the thread of the caller and performs his execution synchronously, has transaction model, so that whenever it's done, boom, things are committed into the database. If something goes wrong or an error is code, then it's easy to roll things back because it's transaction. It's not committed. What we did was we changed the way Camunda is executed without changing the engine itself. So Camunda is a first-class citizen. The execution engine is a first-class citizen in a reactive chain, and that makes it suitable to engage in communication in large service parties with reactive services. So we got true parallel execution for free. We have no async boundaries, with no optimistic lock exceptions. We have no thread that is ever blocked. If we get in this solution, as pictured here, imagine that those two services are web calls and they take maybe a couple of seconds. When you execute them in parallel, what you want is that, well, you just wait until they're ready. You don't want to lock your threads. If you run 1,000 parallel execution of this kind in Camunda, you would typically end up with at least 1,000 threads. If you use asynchronous boundaries, then you would get even more. In lab tests, so disclaimer is needed here, we're able to run 1,000 parallel processes with just one thread. In real life, you probably would have a small pool of maybe something in between 5 or 10 for this type of load. That's pretty cool because it frees up from the need to worry about execution. So whomever writes the BPMN, they just need to take care of writing good business logic. Now, spot the difference here. Camunda has the Java delegate. The Java delegate is a method. Well, actually, it's an interface, but at its core is a functional interface with an execute method that returns void. The idea is that everything would be proxied, carried around by the delegate execution, which is something very much akin to a context. Here, instead, we return a type. And we have specialized activity behaviors. In this case, you see monotask executor, which implements the interface. And what you got to do in order to get these services reactive is implement the method over there. So you see it returns a mono JSON. What does it mean? Well, if you're familiar with JavaScript, a mono is kind of like a promise. If you're a Java person, that is something similar to a future. But it's at the core of Reactor and Webflux in Java and Spring. The type of the mono that is returned is essentially the payload that at some point, when I/O completes, will be returned to a process. And we can just bring it back into the execution as any other variable. We can also do sync services, and there's a bunch of stuff that doesn't make any sense to make asynchronous just because we can. So there is a callable task executor, which allows you to write services which are inherently synchronous. For example, sending a mail. Java mail is synchronous by nature. The fact that this will become asynchronous is done behind the scenes. You never have to worry. So as you compose your BPMN and you send emails, emails will be sent asynchronously. Reactor behind the scenes will take care of setting up elastic thread pools in order to run this on a separate thread if needed. I mentioned the execution, typically used as the context, propagate variables in input and spit it out as variables in output. It's just a traditional way we kind of get the data moving within the process. I had two problems with that. The first one is that I don't really like the magic variables. I don't like have a specification that says, in order for this task to work, you need to set up these variables with these names. It will take me forever just to find the appropriate name for those variables. I like to have interfaces. I like to have fluent interfaces. So the input data is always passed as a parameter to our regular method. As you see here, the URL, the data, the headers, these are all defined either in your process, in your configuration, or as input variables in your task in the modular. By doing this, we essentially do not have the need to interact with data execution at all, which is essential if we start running things in threads that we actually don't know where they come from, because the execution might not be available there at all. So I'd say that probably 99% of the services that we ever implemented do not deal with the execution at all, because we pass the parameters as fluent methods via fluent methods, and the results, it comes back as the return value of the execution. So that also gets published as a local variable once it's done. The fact that they all extend the same specialized activity behavior is pretty cool, because it gives us the ability to bundle a bunch of utilities there. So you see all these methods. I can decide within my BPMN if I want that process to be synchronous. Or conversely, if I just want to have it asynchronous, I can have mail asynchronous and a web call synchronous if I wish so. We can set explicit timeouts so that there will be a failure in case the service does not respond within a given allotted time. We can get retries. I know that Camunda can do it, but that's very much tied to the concept of asynchronous boundaries. Here you can retry just about anything. Anything you want, it can be retried for as many times as you like, with a back-off timeout and a global timeout, after which the retry will just bail out. Many times, case in point, sending emails, we don't actually care about the result of our service. So we just want to issue a request and don't have to wait at all. And we can do that by simply calling fire and forget. The last, there are several others that I put in here because I didn't have space, but the last important one is memoization. It allows us in a very synthetic way to mark a service call with a specific key, which could be anything. It could be the input parameters themselves, so that the next time it gets executed, if that key hasn't changed, the service essentially will return the same value. That's super handy if you do, for example, pricing, quoting. Quoting in insurance can take quite some time, very often. We calculate the quotes, and very often that quote doesn't change because the birthday doesn't change, because the smoker status doesn't change, because the gender doesn't change. But we don't want to put too much logic in our process. We just want to say, give me a quote, but memoize it, so that we don't have to add additional complexity. Kafka handlers would be a great topic for another talk. I would just say here that there's a Kafka thing, takes care of brokering messages. These messages are used to trigger services which are registered with very simple annotation. You write a function that does something. For example, copy file from A to B. And you annotate it and you say, well, this is a Kafka handler, and this is its topic. And when you deploy it, that thing automatically will become callable from the BPMN with a syntax like the one that is described here. And that makes it extremely simple to build services and to extend the platform capabilities whenever we have to. Don't forget that sometimes we don't have in our music box all the pins and combs that are needed to produce a particular result. Another interesting part of this implementation is that we have a built-in request response behavior for easy integration. It's a lot more intuitive. And I think the previous talk also kind of mentioned the complexity of doing choreography in Camunda. So sometimes what you like is just to be able to call in a particular service and wait for the response. And the fact that there's a message broker behind the scenes, the fact that things go into Kafka and magic stuff happens, is completely transparent to the BPMN developer. Again, don't forget that the idea here is to do everything super fast and making it super simple for those who have the responsibility of building these complex processes. In order to do that, we said we don't want to transform Camunda into a runtime for executing scripts. So the bar is very low. Scripts are good and great. Sometimes you have to use them. Sometimes it's very handy. But how about having instead a tool belt, a set of tools that we can use to do the typical things that you normally want to do? So in our case, we got JSON as first-class citizen, so everything is JSON. So we want to have a particularly advanced support for JSON to transform data, merge data, all the typical things that you do and that you can't do in code anymore, because essentially you cannot change that code. The other two important things are, one, we need super solid error handling. I'll tell you in a second why, but Camunda does error handling. The BPMN specification dictates how certain behaviors need to be implemented and supported. However, we need some special work here. Monitoring and tracing are key. When the BPMN becomes the single source of truth, the single brain to orchestrate a complex business process, you can't really rely on the fact that we look at it and say, well, that's going to be how the flow will look like. You want to know exactly what gets executed, and you want to know exactly when it gets executed. That's a topic for Optimize, but we didn't have Optimize. And we wanted to do distributed tracing. We wanted to have the full visibility of everything that happens within my execution, even the services that are called from our BPMN. And I'll show you in a minute how. If you ever dealt with variables and JSON things, you know this type of case. You got, it's essentially a time bomb that is often just there, sneaking in your code. Now pointer exceptions are bad. When they happen, the inevitable is not as pleasant as we wish they were. So what can we do for that? We provide an advanced JSON support extension, which essentially wraps JSON so that we will never, ever get null pointer exceptions. It also allows us to move within a JSON tree, even if this doesn't exist, just to decide at the end that we want to set a particular value. You see the third example. The child in red does not exist. It's the one that was thrown in the null pointer exception in the previous slide. And yet, I can still set a value for it, and the tree will be built for us. If we take the last one, we could do the same. If instead of calling exist, which of course we will return false, we set a value to it, it will automatically create the XYZ structure. So we have solid JSON support, which makes it very easy and handy to deal with it without having to worry about it. And we provide also the capability to do common operations on JSON. For example, merging. For example, applying defaults, aggregating things, transforming from a data structure into another. Two-ways merge, obfuscation. There's a whole topic related to security and GDPR, data protection. Everything that we store within Camunda, for example, is always encrypted, and the BPMN writer doesn't know. But all the variables are always stored in the database encrypted, and they are decrypted when they come out. When we do reporting, we post into Kafka, and the keys that are specified as sensitive data, they are encrypted as well using PKI. There are a set of rules that can be configured in order to wipe the data after a given amount of time or under certain conditions and so on. This makes it easy if you have a particular data structure that is not necessarily known to the system to apply the same level of obfuscation. That's very handy. The last one, as I say, least but not last, is the schema validation. We do a lot of schema validation all over the place. Why? Because it's super handy. Because you can use a schema validator instead of doing a very complex expression to evaluate whether the data you have is correct, is consistent, is as you expect. It also does some nice things for you. For example, it can apply default. Most importantly is the thing that allows not only to expose the commands, the operations, the events that are possible to, that are exposed to drive the different processes, but also how the data has to look like. Error handling. I have 2 minutes left. Great. All errors must be caught. We are in a loop. We execute things. We wait for events. We can't afford to get things to go out of control. It's good hygiene anyway to deal always with your errors. And sometimes having boundary events, they're powerful, they do a nice job, but it's not always ideal. You end up cluttering a BPMN with so many boundary events, and you have to know really well what you're doing. And at the same time, whomever did the service that you're calling needs also to have some degree of hygiene in being able to distinguish a technical error from a business error. I tell you, it never happens. So what do you do? When we deploy the BPMN, this gets patched at runtime. What does it mean? Before it gets actually deployed, we process it and create a bunch of connections that didn't exist before. so that we have error handlers. This slide is, I've made it for some other purpose, that's why there's so much text, but that essentially explains the idea. The yellow boxes are error handlers. The simplest possible task in the modeler, you go in the tab extension and you just set which codes this error handler will want to deal with. It could be Java lang exception for all the technical errors. It can be star for all BPMN errors, or anything in between. Just BPMN errors with certain codes or certain specific technical errors. This is a catch-all and it's process-specific. What is presented here is different ways of using it. For example, in the green box, we have a catch-all error handler, which is specific to that process. So we'll catch only things that happen in there, where we convert a technical error into a business process error. Because the guy or girl who made the service, in the first place, didn't really have the notion of a business error. So we get like these funny exceptions. But in the context of our BPMN, we want them to have a different meaning. Mentioned tracing before, and this is the last part of the topic of the presentation. Open tracing, if you're not familiar with it, it's an industry standard. Plenty of Java libraries provide instrumentation already available, JDBC, any sort of serious library has some form of instrumentation that is available, typically for free. Open tracing itself is vendor independent, so it doesn't actually matter what you use for collecting these traces. It's fantastic if you want to do distributed performance monitoring across different services in a distributed system. Camunda does not support it, so we implemented a plugin that brings automated instrumentation to Camunda as well. What you get with it is something like this. What you see on the left, what you don't see on the left, but you have to imagine, is the list of tasks, is the hierarchy of tasks within our BPMN. And you know exactly what happened, when, how long it took. The different colors are different services. That's the distributed end-to-end tracing that everybody talks about, and that hopefully Optimize will bring in the future. You'll have the complete visibility of what happens. This is not a tool to replace Optimize. Optimize does a lot more, and it fits a different type of use cases. This is extremely handy as a developer to have, because you can see in real time, all the time when you develop, when you modify your business process, you run it, and then you have the complete trace, and you see if really the parallel gateway is parallel, how long it's taking, how much work Camunda does when it talks to a database, because the database is instrumented as well. And that's pretty awesome. So check it out. This was the last part of my topic. Get in touch. I'm going to be around also for lunch, and then I have to fly back home, which is here in Zurich. If you ever happen to be around there, that's where our office is. Actually, there's a sex shop. You just have to go to the next building. Thank you.